Okay, for number 10, I know they're not giving us a picture of it, so I want to go to the whiteboard and do some work on the problem. But we'll certainly arrive at the answer. At least I hope I arrive at the same answer they got here, and we'll come back to it. So I'm going to go to the whiteboard, and I'll write it down for you. So this is number 10. And for number 10, they want us to do something. And first of all, I always say visualizing it. Now, the prior problem certainly had pictures, but I need to visualize this over here. R equals, and that looks like 12 sine theta. And again, some people are better than others at recognizing things. You should realize if you're given a problem like this and you need to visualize this thing, rest assured it's probably an easy visualization. The first thing I would do is multiply both sides by r. What do you get? R squared equals, and again, I've not even read the question except for this over here. It would be 12r sine theta plus 12r cosine theta. R squared. Oh, you know what I know what r squared is. It's x squared plus y squared. I'm going to go to Cartesian. That's the whole point of this. 12. And r sine theta is just y. Plus 12. R cosine theta is just x. So I got a pretty good idea that I can visualize this thing. Let me just rewrite it. X squared minus 12x plus y squared minus 12y is equal to 0. I'm going to complete the square. Half of minus 12 is minus 6. Square it is 36. Let's see what else I got over here. Half of minus 12 is minus 6. Square it, 36. Kind of nasty, right? What do you have here? X minus 6 squared plus y minus 6 squared. And 36 and 36 is 2 times 36. And I think I know what this is. A circle. Center is going to be 6x. And the radius is going to be 6 times the root of 2. I'm not great at drawing pictures over here, but I do want to get a sense of what this thing looks like. And let's see, center 6x. I'll just say it's right about here. The radius is bigger than 6. So I'm going to say, maybe something like this over here. And again, I'm really bad at drawing pictures. All right? Then someone says, well, I wonder what the question is. I don't know. I have to read it. It says, find the area of the part of the circle that's in the fourth quadrant. This is the fourth quadrant. I got a couple things to deal with over here. And one thing I deal with is, what these points are. All right? So I'm going to say, they don't look that bad to do, but I do have to figure them out. All right? So what do I know about over here? I know something about this. I know the y is 0. All right? I know the y is 0. Now, if the y is 0, I have to figure out the x is. And let's see if we can do that. And again, I'm looking at the picture, by the way. So if the y is 0, you'd have x minus 6 squared. Oops, sorry about that. I didn't mean to do that. Plus 36 is equal to, again, if y is 0, you get minus 6 squared, which is 36. 2 times 36. So you get x minus 6 squared equals 36. So x minus 6 is plus or minus 6. So x is going to be 6 plus or minus 6. So this point over here is 12. And let's see, 6 plus 6 is 12. My picture's not very accurate, is it? Because the other place would be over here, actually. So I got to revise my picture a little bit. Not a bad thing to do, right? So let's do that. And I'm going to redraw it. sure I should that right, though. X minus 6 plus or minus 6. So it's going to be, yeah, 12 or 6. It looks like this over here now. All right, let's put this down. So the point I get here is 0, 0. And the point I get over here is going to be, and this is the fourth quadrant, the place I need to get that over there. Really doesn't look that bad, actually, does it? So what do you get over here? Let's take a look. I think I just did it, right? Oh, yeah, 12, 0. All right. And what do we got here? We have a region. And I got to figure this out now. And I got to think for a second. And the way to think about this, I still have my point up here, right? Right, there's an angle it cuts through, right? Let's go for that. All right, let's take a look. Let's kind of figure out where this is occurring. And I want to make the R to be 0. Because I'm kind of looking for this thing over here. All right? And then we'll talk about making the R 12 and things like that. Shouldn't be that bad. So make the R 0. I'm trying to figure out what the theta is. And if you did R 0, you'd get, 12 sine theta plus 12 cosine theta is equal to 0. And let's think about that. That's going to be, I'd have to get the sine of theta to be the opposite of cosine of theta, or vice versa. So I'm going to say minus 1 tan theta. All right? And let's just think about that for the moment. And, I'm going between 0 and 2 pi. And what I want to do is, when does the tangent become minus 1? And if I thought about this, it's really at minus pi over 4. But what I got to do is it's a cycle length, and I got to add on to it because I want to stay between 0 and 2 pi. It's just for me, my convenience. You could do it otherwise. And the cycle length for tangent is just pi. So it's going to be 4 pi over 4. What's that going to give you? 3 pi over 4. Let's write that down. 3 pi over 4. Not so bad. All right, I got the theta 3 pi over 4. That's when that's going to occur. I got to keep going through this, don't I? And I got to think now. And what do we got to think about? We got to think about where this thing is over here now. And that means the R is 12. Right? But the R is 12 here. All right, the R is 12. So if I wrote that down, the R is 12. What would I get there? I would get 12 equals 12 sine theta plus 12 cosine theta. Divide by 12, you get 1 equals sine theta plus cosine theta. I got to think about that now, don't I? And I don't think that's right. I'll tell you why. Because I need to go forward from 3 pi over 4. I need to go forward from that. So I'm going to say, instead of 12, I'm going to say it's minus 12. In other words, it's over here somewhere, and then it shoots back over there. So let's put the minus 12 down instead. Minus 12 equals 12 sine theta plus 12 cosine theta, which means minus 1 sine theta plus cosine theta. And again, I want to move forward from that 3 pi over 4, moving forward from it. You know, and again, I'm kind of looking at it. And that would be what value? I'm not going to too much work on it. I mean, if I was in pre-calculus, I'd probably be squaring both sides and trying to think about that. But I don't think that's productive. I'm going to say it looks like it occurs at pi. That's certainly above 3 pi over 4. Remember, I'm moving forward from 3 pi over 4, but I'm not going to go past 2 pi. So let's take a look at that. Sine of pi is going to be -1. Sine of pi is 0. The cosine of pi is -1. Yeah, it works good. So I'm going to say this occurs. This is the first one. Theta 2 is going to be pi. All right? So I realize it's tough. Right now, you say, what are you doing now? Let me just read that again. Find the area of the part of the circle. Well, you know, it's a part of the circle now. It's that part of the circle. It's that part of the circle. That's the part of the circle. Let me just read that again. Find the area of the part of the circle in the fourth quadrant. And I got to think now. Part of the circle in the, yeah. The part of the circle in the third quadrant. Got to think about that. Let me get rid of the bad picture too. I want to get rid of that. I'm just sloppy. Let me see. Find the area of the part of the circle in the fourth quadrant. Let's write it down. We're going to start at 3 pi over 4 to pi 1/2 theta, that's d theta, r squared. And what's the r squared? It's 12 sine theta plus cosine theta. I'll just write it down. 12 sine theta probably should reword the question, I think. Let me see if I'm saying that right, though. And I think I did okay. Well, factor 12 is 144. And half of 144 is going to be 72. I'll write that down for you. This is the area. Three pi over 4 pi I have to square that. Sine squared plus cosine squared. And then it's going to be, let's see, you would have, sine times cosine, 2 sine cosine, d theta. All right, I certainly know what sine squared plus cosine squared is. Let's write this down. You know what? I misread, and I have to go back and erase this. And I'm sorry about that. I really did misread. I'm going to erase here. And it's probably, I don't know, maybe it's I can't really make excuses, but it's not this. The section that we're doing here is this section, and I apologize for that. This is the theta 2, that's a theta 1. Sorry about that. I just misunderstood that. And it was not the right integration anyway if I did that, but it would have been an easier question. So what I got to do over here, it's the area of the circle in the fourth quadrant. This is what they're talking about over here, all right? And that's the section is going to sweep that out. I'll probably post a video of me sweeping out this section, and I'll probably use Wolfram to do that. So what do you get over here? You get 1 plus, that's going to be sine of 2 theta, right? Makes it easier for me, by the way. Let's keep moving. 72. You're going to get theta minus cosine 2 theta over 2. Limits of integration are going to go from 3 pi over 4 to pi. And I got to do the arithmetic now. And what do you get? 72 pi minus, the cosine of 2 pi is 1, so I get 1/2. That's 3 pi over 4. Minus 72, 3 pi over 4, and that's going to be the cosine of 3 pi over 2. And that's going to be 0. Let's keep moving forward. I'm going to get 72 times pi minus 72 times 1/2 is 36 minus 18 times 3. 4 goes into 72 18 times. 18 times 3 is going to be 30 and 24, 54. Going to keep moving through it. And 72 minus 54, that's 16, 18 pi minus 36. And we're done. All right, look at the key, and I'm going to look at that key right now. And I think, let me just look. I see the 18 pi minus 36. Let me see if I got the integration written down as they say I want it. I don't see some of the work written down, but I see enough of it to know that we did okay. All right. What I'll do is I'll post a video of the graph of this, and I'll do that Wolfram alpha separately, by the way. And what I mean by that, I'm going to graph it between 3 pi over 4. So I'll start at theta equals 3 pi over 4, and I'll stop at theta. This is theta 1. Theta 2, I'm going to stop at pi. And what I hope to show you when I do that is you're going to see a graph like this over here. All right? Thank you.